Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about optionals. Optionals are a concept that are available pretty much in all modern languages. You have them in Swift, you have them in Rust, you have them in TypeScript, and of course in Dart. Now, optionals are relatively new concept to programming. Like if you look at from the beginning, like the history of programming, when it was kind of like created and became mainstream up to now. If you look at the entire history, optionals are kind of like a new topic. However, in modern programming language, they're a must to learn. And some developers have a little bit of difficulty grasping the idea of optional values, and especially if you're mixing them with non-optional values, or if you're like digging deep in optional values and extracting some other values from them, they can have some difficulty understanding the concept. So in this chapter, what we're going to do, we're going to start very easy, and then we're going to build on top of the foundation to create some more advanced topics. So if towards the end of the chapter things are getting more difficult for you, it's okay, as long as you just look at the examples and just bear with me while I explain the concepts. And if you don't understand them at the end of the day, you can always come back to this chapter and redo the chapter after we've gone through some more examples of like extensions in later chapters. Okay, so the important thing is just to go through the chapter. So let's start actually creating a folder for our optionals chapter. I'm going to bring up our terminal in here. So let's go and have a look at what we've already done. We've done operators and say git add all, okay. And then we say git commit operators like this. Okay, so we have the previous chapter committed now. And what we're going to do is to create a separate Dart project for this chapter. So let's say Dart create template of console, and then we call it optionals like this. All right, let it do its work, and then we will open Visual Studio Code in optionals folder like this. Then we don't need this terminal anymore. Let's go here, and I'm gonna go into the settings of this project and say zoom level. And I think we set it to 5. If we go back to the operators chapter, let's see what we set the zoom level. I think the zoom level was 6 perhaps. Yes, it was 6. So let's set the zoom level here to 6 as well. Okay, then we can go into the bin folder and remove this file from here, which is called optionals. New file example1.dart, as we usually do. All right, then let's go to our terminal. And let's say that example1.dart should be run with fswatch, a main function, and a print hello in here for now. Okay, and we can see the result being printed to the console. So we have set up our project basically for this chapter. Okay, so optionality in Dart is the ability to have a value or to not have a value. Okay, so either a variable contains a value or it doesn't. Up until now, like we've had a look at, like we said, const name. We can say hello. All right, that's my name, or foo. Now we know that this variable is a string and it contains a value. So if we go in here and say string with a question mark, we're telling Dart that this is an optional string, meaning that it can either be containing a value or it could not contain a value and be equal to null. Okay, so optionality is the ability for a variable to either contain an actual value of a particular data type or not contain the value of that data type and be equal to null. All right, so let's actually clear this. So, and wait a minute, we could leave it, to be honest with you. Let's just say string, optional string, and in here we just say it is equal to null. All right, and then we print the name. I think I didn't actually close something in here like this. Okay, and let's run our application. You can see the value of null being printed to the console. Okay, now you can also print null itself. So when you see null, you can understand that it denotes the absence of a value. Okay, so this null itself doesn't really have a data type at the moment. Okay, and we'll have a look at this, but just know that any data type can be, you can actually postfix you can actually append a question mark to it in order to make that data type optional, meaning that this name now can either contain an actual value of type string, or it can contain null. All right, so that's like a very basic example of optionals. Let's create example 2 in here. Let's say example2.dart, and of course fswatch example2.dart. Let's create our main function and have a look at the next example. Now, if you're working just with the value of null and you don't actually have a data type for it, Dart understands that value to be of type dynamic. Okay, and this is something that you will come across perhaps more and more advanced you get at Dart, and it is just some data type that you could say it's equal to like the any data type in Swift. For instance, okay, if you're familiar with Swift, it can pretty much represent any other data type. So let's write some value in here, and then we say it's equal to null, and then we say print some value. And if you look at the data type for some value, you can see it is dynamic because Dart doesn't have understanding right now of what null represents really. Is it a null integer? Is it a null string? Is it a null double? You can actually tell it. You can say this is an actual optional double, which is equal to null. And it's fine. It still prints the value of null for you. You can see in here, but at least understands that some value is now an optional double. However, if you don't give it a data type explicitly, null in itself is a dynamic value. All right, so that was for our example 2. Let's go to example 3. Example3.dart. Okay, create that file. Now, you can also compare nullable or optional values to the value of null. So let's run example 3 and we have our main function. Let's say we have an optional integer which is equal to 20. All right, so it is we're telling Dart that this is a variable that can either be null or it can be any integer. That's what this question mark means. But if you tell it that it's an integer and then go and say it is null, then Dart doesn't like that. It says, oh, null indicates the absence of a value, but your data type doesn't allow that. In order for this data type to allow the absence of an integer, you have to make it nullable, which is denoted by this question mark in here, okay? But we say age is 20, and we say then age is null. You see, it allows both entering a valid integer, and also it allows entering null. All right, and then we can print the age, print age in here. Okay, you can see the value of null being printed in here. Then we say if age is null, so you can compare basically a nullable value with the an actual null value. Then we say print age is null, and let's see if we can get some help from GitHub Copilot, and it did help us. Age is not null. So you can see now if we run our application, let's bring up the terminal. I think I accidentally closed it. There we go. First, we got the value of null printed to the console, which is right here. And then we're comparing age with null. And it says, yes, age is null. And if we go ahead and comment this line out, for instance, Dart completely understands that, oh, wait a minute, you actually told me that age is 20 already, but then you're comparing it with null. This condition can never happen. Now, this is like some static analysis that Dart is using under the hood in order to understand what is actually happening in here, okay? So if you had a function that accepted an integer, like let's actually create a function in here. Let's say void something, and then you take an integer as a parameter, okay? And then you wrote the exact same code in here. Let's copy it and paste it over here. Then Dart doesn't really understand whether this age is indeed null or not. So it can't complain that, hey, you're comparing age with null, but it can never be null. In this context, Dart doesn't understand that because, well, I'm just taking an optional integer and comparing it with null. So in that context, it's not possible for Dart to understand what you're actually doing. So it can't do this complaining that it was doing right there. But in this function, in the main function, since it already knows that age is 20, and after that, age is not being assigned to anything else, then age cannot be null. So the static analysis can basically be a hit and miss. You can't just always rely on it, okay? But the point of this example is that you can always compare a nullable value to null. And if it is null, then you can do your branching. And if it is not null, you can do something else, okay? So let's save this example 3 as well and go and create an example 4.dart. And fswatch example 4.dart, like that, main function. Okay. So nullable variables, the point of this example is to explain that nullable values by default in Dart are actually null. What does that mean? Let's say that you have an integer and you say int a, all right? And then you try to use this a. So you can see that Dart says, hey, you can't do that. A doesn't have a value. You said that it does, but it doesn't really. Then you should go and say a is 20, and then you can use a. However, with nullable values, if you say string like this, last name, okay, you can see it is fine. And then in here, you can actually say print last name, okay, and everything's fine. You didn't have to initialize this variable. You didn't have to say, okay, it is like, if you go back to this example, you see this wasn't a valid code. However, when you're working with optionals, if you say string last name and then prints the last name, you can do that. And if you run it, you can see the value of null being printed to the console. And simply because optional data types in Dart for variables are by default initialized to null. So this is the point of this example, okay? And I'll also throw in a little bit of a fun operator in here, which is the Null-Aware Assignment operator. And in here, what we can do is to say last name, question equal, and then we say bar. What does this do? Well, it is an operator that assigns, as you can see, it is a compound assignment operator. It's a null-aware compound assignment operator. It is a mouthful to say, but whenever you see an operator to the left-hand side and an equal sign to the right-hand side, it is a compound assignment operator, okay? And what this does is that it tells Dart that assign the value to the right, to the variable on the left-hand side, only if the variable on the left-hand side is null. So in here, you can see last name doesn't have a value and it was null when we printed it to the console. If we run this application, now last name is bar, simply because last name was indeed null when we came to this compound null-aware assignment operator. However, if we go ahead in here before this statement and say last name is Baz, and then run the application, you can see then Baz is printed to the console. And we're getting this warning as well, simply because Dart is doing some static analysis. It's understanding that, well, last name isn't going to be null, and you're here using this operator. This is kind of meaningless. And simply because it, in this context, understands what you're doing. But if you actually went ahead and created a separate function and took in an optional last name, and actually, in that context, it would also understand it, perhaps, even if this was a separate function, because yes, the line before it is actually assigning last name to another variable, okay? But if you had two optionals and you were assigning the last name optional, another optional string to this before this line, Dart wouldn't understand that last name is indeed not null. Here's an example. Do something and you take in a string 1 and a string 2, okay? So in here, we can say 1, question 2. So what happens in here is that Dart analysis doesn't really understand that this variable is indeed, or it can't. I mean, there is no way for Dart to understand that 1 is not null, because in here we're saying that it's a nullable value or an optional value. And what we're doing in here is saying that if 1 is null, assign the value of 2 to it. However, 2 could also be null, but it is fine because 1 is a nullable data type and it can be assigned to another nullable data type or vice versa. But I understand it can get a little bit complicated to have think about. It can be a little bit philosophical sometimes, but just know that, I mean, when I'm working with, sorry, I kind of abruptly terminated my sentence right there. It's just because I want to say something else, actually. What I think about when I think about optionals is just Null values, that's the only thing that comes to my mind. Is it null or not? Really, optionals are all about that. Is it null or not? So, and there are some funky operators that you can use in Dart in order to unwrap these values. Okay, so just know that you're pretty much just playing with null values. Okay, or sorry, you're playing with nullable values. So let's go ahead and create an example 5 in here and a main function, the usual dance. Okay, example 5. Good. And let's see, actually run our application. Okay, now let's talk about the Null-Aware Operator to access properties and methods of nullable values. So let's create an optional string in here, and we say some other last name, okay? Or we could just say last name, it's fine as well. Now, let's say that you want to get the length of this variable. Since you already know that in Dart, by default, the initialized value, the initial value of a nullable variable is null. We already know that. We learned that in the past examples. Now, what happens if you want to get the length of this guy? Like by default, if you say final last name is foo, you could say last name dot length. So let's print this to the console. You can see you get the value of 3 printed to the console. Okay. But what if you have this example? We have a nullable value in here. Okay. And we want to get its length. So let's say print last name dot length, and you can see in here, then you get an error. So Dart isn't able to compile this code simply because values that are of type optional, so this is an optional string, and this is an optional double, this is an optional integer, and this is an optional list. So any one of these data types that has a question mark right after the data type itself is a nullable data type or an optional data type. Okay. Now, if you want to access a variable that is optional, or sorry, if you want to access the properties of a variable that is an optional variable, then you will need to use the null-aware operator in here, the null-aware operator to access properties and methods. So you put just a question mark right after the variable name itself before you use the dot. You see the difference? Question mark. Okay, so what is this gonna do? It said null, but what if this guy was foo? Then we get the value of 3. Okay, so you're pretty much accessing properties of an optional value in here. Okay, let's go and see another example. So I'm gonna scroll a little bit so we don't see the previous example. Let's say string null name. Okay, and let's make this an optional value. Now let's have a look at the null-aware operator that looks at the left-hand side and then takes the value on the right-hand side if the left-hand side is null. You already seen this example, which was the compound null-aware assignment. Remember? So it took the value to the right and placed it to the left-hand side variable only if the left-hand side variable was null. Now, if you take this equality out of this operator, then you're only left with the null-aware operator in here, which takes the value to the right hand side and uses it or returns it only if the left hand side is null. There's quite a lot of difficult sentences maybe to understand, but let's have a look at an example. Let's say print null name, okay, in here, and we then of course get the value of null printed to the console. However, if we say take this null name or the value of foo, what happens then? Well, it took foo because it looks at this and says, oh, this is an optional string, but the right hand side is not an optional string. Then it goes into this optional string and says, oh, are you null? Yes, I am null because it doesn't have an explicit initial value, so implicitly it's set to null. Then it takes the value to the right hand side. If you assign this final blah, if you assign the result of this statement to a variable, unsurprisingly, the data type is a string. But what happened here? Why is it not an optional string? Well, it is purely logical. It says, I'll take the value to the left-hand side if it is not null. It was null. Or I'll take the value to the right-hand side if this was null. However, the value to the right-hand side is guaranteed in this case to not be an optional value. It is a value that is present. It is a constant string. You can see in here, okay? So even if this was null, the value to the right-hand side is not null, meaning that the result of this statement completely is guaranteed to not be null. All right, so it's just logical. However, if you had another string, a nullable string, and you said blah, or let's just say foo, and then instead in here we said foo, all of a sudden the result of this is an optional string. What happened here? Well, Dart looks at the data types. It said on the left hand side is an optional string, on the right hand side is an optional string. I cannot guarantee that none of these are not null. Or at least I can't guarantee that at least one of these guys is containing an actual string. Therefore, the data type, the return value from this operator is not guaranteed to contain an actual string. Therefore, it is optional string. Okay. However, in this example, Dart looked at both left-hand side and right-hand side and says, oh, I have an actual string in here. It's not optional. So I can really guarantee at the end of this operator that either I take the value of this guy and return it if it's not null, or I'll take this guy. So I am guaranteeing an actual string. Okay. I mean, to be honest with you, it's really logical. So it's kind of like I give you one bag and I'll tell you that this bag either contains some coins in it or not, or it is empty, okay? And I will give you a second bag and I'll tell you that this bag for sure contains coins, and you feel it and you understand that it contains coins. Then I'll say, given these two bags, give me one coin. Can you guarantee that? Well, logically, yes, you can guarantee that, because you know that even if the first bag is not containing any coins, the second bag does have at least one coin in it, so I can guarantee. But if I gave you two bags and I said you can't feel them, but they both could be completely empty, or they both could contain some coins, or one of them could contain some coins, what would you return? Can you guarantee that you can give me a coin? No, of course not, because you don't know if any of these bags contains a value, or a coin in this case, okay? So that's how Dart reasons with these variables. So let's put our print statement back in here, okay? So let's go in here and say print, actually, let's print our last name in here. So we say print the last name or foo, then we get the value of foo. Then let's say print the last name or null name. What happens in here, it says both are null, so the result of this is null. You can see that printed to the console. And we could also chain these nullable operators, null-aware operators, and say last name or null name or bar. Okay, so what happened in here? Dart goes and starts resolving these operators from left to right. So it says, okay, first I'm going to resolve these. Oh, this could be this could either be null or not. This could either be null or not. And so the result of this is an actual optional string. Then it says, oh, an optional string or bar. Then it says, okay, this is null, therefore this is null. Like this. So it says, okay, so should I take null or bar? Then it takes bar, because you're basically, this is what the job of this operator. It takes the non-null value. So if you assign this to a variable, you'll see, what can you actually guess what this data type is going to be? We've already talked about it. So here is like you have three bags. Two of them could be empty. One of them is guaranteed not to be empty. So the result is a simple string. So you can see it's not an optional string. It is a simple string. Okay. So again, this is just pure logic. Just think about those bags with money or coins in them. Okay. So that was the point of example 5. Let's go ahead and close this guy, and we're gonna create a new file, example6.dart, and let's stop fswatch example6.dart like this, a main function. All right, so up until this point, we've talked about data types that are nullable, but you can get some data types in Dart that are nullable even inside of them. And what that really means is that these are container data types. And one of the most simple examples of a container data type is a list. Okay, so let's go ahead in here and create a list. So let's say we have a list of strings and we say names. All right. However, let's make this list an optional. wait a minute, where do we put the question mark? Here or here? They seem to both be valid. What happens is, if you put a question mark in here, you're saying that this entire list could either be null or it could actually be some names. So putting a question mark in here, it makes the list an optional list. So it's as if you just wrote this, okay? And also, additionally, you can go ahead and say this optional list of strings can actually now become an optional list of optional strings. So both the list and its contents, both the list or its contents could be nulls. So I'll show you some examples of valid values that you can assign to this variable. One is that since this list could completely be null because of this question mark, you could just say null in here. So that's an example of a valid value that can be assigned to this list. Another example is that you can assign it to an actual list of strings that is empty. So it is an actual list, but it's empty. Or it could be a list of valid strings. All right. Or it could be a list of valid strings and some nulls in it, because this null is then treated as a null string, basically, okay, as a nullable string. So these are some valid values that you can pass to this particular list. So container data types such as lists can themselves be nullable, and they can also contain nullable data types, because here really we're dealing with two data types. One is a list, the other one is what it contains, which is in this case a string, which themselves can be nullable. Okay, so let's go ahead and say names, and then we say add, and then we add the value of foo in here. Okay, so what happened in here, we said names, and you can see we were using the null-aware operator in here for accessing the function add. If you remove this, you can't access add anymore because it says names could be null. So you can't just go and call a function on it. You have to say if names is not null, then use this function. And this is what this operator is doing here. Okay, so we're saying if names itself is not null, then go ahead and call the add function on it and add the value of foo to it. All right, and then we can say names also add the value of null. That's also possible simply because we're saying that this list can contain nullable strings as well. Okay, and then we print names. All right, let's see the result. What do you think is going to happen? Wow, we got the value of null. So none of these functions actually did anything simply because names itself is a null list. All right. However, if you went in here and you actually initialize this with a non-null value and you ran your code, you can see foo and null are indeed added to this list. Okay, now you can see that we're getting some errors in here, and it says the receiver can't be null. So that's very interesting. Now all of a sudden you can go and remove these from here simply because Dart already knows that this names is not a null value because of this. But what happens if you go in here and say names is null? What happened here? Can you then copy paste these lines of code in the next line? Oh, it didn't work. The static analysis is understanding that after this point, names is null, so you can't call these functions. And to be honest with you, I personally don't like how Dart handles this. Dart is trying to be too smart about the contents of this names variable, and it understands that in this case, names is null, so you can't just call an add function on it. You have to do the null-aware add as execution. And in this case, it knows that names is not null, so you can just go ahead and say dot. And this could be really confusing for people who are coming to Dart. And to be honest with you, I use Rust and Swift almost on a daily basis. And I think those languages have implemented optionals a lot better than Dart has, because this code is just, to me, it looks really confusing. Because here I can just call add, and here I can't. But that's just the way Dart does it. Okay, just know that Dart is doing some static analysis to understand the contents of this variable. Okay, now what do we do if we want to extract the first value? Let's actually remove these and put our question marks back. Now, what do you do if you want to grab the first value out of this names variable? Now, because remember, this is a list, okay? So if we go ahead and say final, first is names, optionally take the first value, okay? Now what happens in here first is going to be an optional string, okay? Because it says, okay, first of all, I don't even know if names is null or not. And in this case is null. So the first variable inside it is for sure null because this is null. However, the implementation of the first property, this thing, is not returning a nullable value. So this is another beef that I have with Dart, in that it's a relatively new language. However, it's already has bugs built into it. Again, in many other programming languages, such as Rust, the first element inside a list is always a nullable value, because you can have lists which are empty, and Rust cannot guarantee that that list contains even any values. So the first element could be a null value, okay? So the way Dart has implemented it is that this first property always returns a value. So if we go ahead in here and create another list, let's say a list of strings, names2 as empty, and you say final, blah is names2 first, then Dart says, ooh, it's a string. But it can't know that. I mean, it is indeed a bug, and this is going to crash your application. But in other programming languages, which are modern, of course, kind of like Dart, which don't have this particular bug in them, the first element of a list or an iterable is an optional value. So your program won't crash in other programming languages, but just be careful doing that in Dart, and because that type of code will crash your application. So enough about that. Now what happened in here, we said first is go to this list, optional list. If it is not null, grab its first value. And the result of this is an optional string, of course, okay? So we can say print this first value or no first name found, all right? And run our application. You can see the value of no first name found is printed to the console, simply because names names didn't have any values in it, actually. It's a null list, so it's as if we just typed this, okay? Good. Now we're done with that example. Now, local nullable variables get promoted to not nullable when assigned to a non-null value. We've already seen this example, so I don't have to explain it too much, but I will just show you. So if in here you say names is a list now, is a valid list, but is empty, after this line, until names is set to null again, then you don't have to use the Null-Aware Operator in order to access the properties and functions of this variable. So you can say names, add, baz, so you don't have to do question mark. You can do it, but you shouldn't, okay? And then, I mean, you shouldn't, simply because right before this, you actually assigned this names variable to a valid array, which is empty, but it is still a valid array, which is empty with no elements in it. Therefore, you don't have to do the null-aware property accession operator. I'm just making this name up, but it's like a null-aware operator, basically, okay? And then in here we say names add. We can say null in here. Okay, you can actually add a null value as a null string. It's pretty much saying like this, okay? But you can't type that in Dart. In some other languages, you can say a string like this and null, okay? But in Dart, you can't do that. But here we're just adding a null string basically to our list, and then we can print our names in here like this. There we go. Then you get a list which has the value of baz as its first element and then null as its second element. All right. Now let's go ahead and move on from this example 6, and let's go ahead and create example 7, Dart, main function. Then we go and say example 7 in here, like that. Okay, good. And now we have our base. Now you can also use the exclamation mark operator to force a nullable value to be unwrapped, but this is unsafe and causes your program to crash should the value be null. So let me just explain what happens in here. So if you go ahead and say final string, an optional string, first name, okay, and if you just leave it like that, that's fine. Or you could just say it is equal to null, all right, but you shouldn't really have to do that. You just say it's it doesn't have a value, which means it's implicitly set to null. All right. And if you say print first name, all right. Oh, it says it can't be read. It's because it's final. If we didn't have the final, then we wouldn't get that error. But since we have a final value, it means that this variable needs to be actually set to some value before. This variable should be set to a value before it's used. So we either remove the final or we leave the final and then we say equal to null. All right, this is also fine. So maybe let's just leave it like this so we see an example of doing a final nullable value set to null as well. So we have the first name in here. However, if you use this operator in here, what happens is that you're telling Dart that I want to force read the contents of this value. What happens in here is that, let's say final blah or final foo is this, so you see what Dart does. Though first name is an optional value, is an optional string, nullable string, if you do this operator right after it, the result of this is not an optional value anymore. So what you're telling Dart is that I don't care what is in this variable, if it's null or not. I want you to read its value. I want you to read its contents. So what happens is, in this case, since this is null, you cannot read the contents of null. So your program will crash. So let's print this. So we're risking our program crashing. So let's just run the application and see what happens. And surprise, surprise, we'll get an exception in here. It says null check operator used on a null value. All right, so our program is crashed now. So if I do Command S, fswatch can't recover from this. Let's just say fswatch one more time and put this thing inside a try and catch block. So let's go ahead in here and say catch, and we catch an error. We will talk about error handling more later, but for now we just do a try and catch block. And you can see our exception being printed in here. It's simply because we have a print statement in here. Okay, and if I remove this, just nothing happens. It's just an empty terminal. All right. So this is an exception that you can catch, but I have to tell you that I never do code. I never write code like this, and you shouldn't either. And the reason behind that is this operator is intrinsically very dangerous. It's because you're force unwrapping a nullable value, meaning that you're actually risking being wrong 50% of the times. So your nullable value could either contain an actual value, it could either contain an actual string, or it could be null. The chances are 50-50. So by force unwrapping it, by force reading it, you're risking being wrong 50% of the times, and that's not a good risk to take when you're writing production level applications. Okay, so please don't do this. I just wanted to demonstrate that it is possible to do this, but you should never write code like this. You should always ensure that your code can recover from situations like this. So in this case, we're saying that, oh, I want to read the first name, but do you really have to? No, because you're just printing it. So what you could do is say you either read the first name or say no names found. Okay, that's a lot better to write than all of this code that we just written. So you could just remove all of that. Okay, so when you see this operator, I don't even know what they call it. Let's see, null check operator. When you see this code, just become very aware that you shouldn't do stuff like this. All right, it maybe in some cases you actually need it, and you should have a really good reason for actually using it. Okay, but otherwise, please don't do what we're doing here. It's just an example what not to do. Okay, so let's then close this example 7 and create an example 8 Dart in here. Okay, and we can stop fswatch main function in here, and let's go to our example 8 like that and save this file. Okay, now you can promote a type to not nullable by checking first if it is null or not. Now, what does that mean? Let's go ahead and create a final variable in here. We say final string first name, and we explicitly set it to null because it's a final variable. Okay, now you say if first name is null, then you can print and say first name value is null. All right, however, if you create an else branch in here, what happens is that first name, even though it could, let's see what it thinks, even though in here it says is an optional string, But you can actually grab its length, for instance. You can access its properties without having to do the Null-Aware operator, of which is like this. Okay, so let's go ahead and get the length of this first name. So we say final length is first name, and then in here you can't say dot length because it is a nullable value. So you have to say question mark dot. However, if you move this exact same code to this else block, you will get a warning saying that, hey, this is not necessary anymore. Why? Simply because we're in an else statement in which the if statement actually already checked whether this value is null. So if you happen to end up in this else statement, first name cannot have been null, because otherwise you would have gone into the if block. So if you happen to end up in the else block, then first name cannot be null. So you can remove this from here. Okay. So then we can print length right here. Okay. And this is of course an integer. Let's put int in here so it is explicit and very visible what it is. So the goal of this example was really that if you happen to have a variable which is nullable, you can check it against null, and in the else block you don't have to worry about whether that value is null or not, because if your if block checks for that, the else block ensures that that value is not null, so you don't have to do all this monkey business in here. Okay, so let's close example 8 and we will create example 9 in here. Okay, oops, example 9, and do the same thing with fswatch in here, example 9, and a main function. We've already done these many times before. Okay, now in typical Dart code, in the modern Dart code, you probably are going to end up with situations where you're using both the this operator and also this operator. Okay, so this one was an operator that allows you to access the properties and functions of a nullable value, and this is the one that took the value to the left hand side, took the value to the right hand side if the value to the left hand side was null. All right, let me show you an example. Let's create a last name, and we say this is an optional value. All right, then inside the main function, we create another function. We call it void change last name. All right, so it's a little bit of a sneaky example, really. You usually don't see stuff like this in real life. You could, I mean, some cases this could actually be a valid thing to do, like having a function within another function. I've actually done a few of these things before. So in here we are going to change the last name to bar. All right, so last name is null by default, and in the function we're changing it to bar. So let's go ahead and call this function. All right, and then we say if, and actually this is interesting now, because if you say final foo is last name, foo is an optional string. However, if you look at the flow of the application, first last name is null, then we have a function which we're calling in here right after this, which sets the last name to bar. However, Dart doesn't understand that after this line, since we've called this function which sets the last name to a valid string, the last name is still an optional string. So the Dart analysis does its best to understand the context, but in this case, it was too complicated for it to understand that after this line, last name is not null. All right, so that's why I said a little bit earlier that the Dart analysis is a little bit of a hit and miss. You can't really rely on it 100% of the times catching all these cases. All right, so let's go ahead in here and we want to search for the string bar in this last name and see if it contains that. So we say if last name optionally contains the value of bar. And you can see in here we're getting an error simply because the value of this function is an optional boolean. I mean, when I don't understand these things, I go ahead and assign them to a variable. So I say final foo is equal to this, and I look at the data type. Oh, it's an optional boolean. So what it is complaining in here is saying you can't if on an optional boolean because this may actually be null. If null, I don't know how to solve that, says Dart. Okay, so you can in here say if optionally reading the contents of last name and checking whether it contains bar or not, or the value of false. Okay, do you see what happened in here? So we said take this and see if last name contains bar. But since this is an optional value, which could be true, false, or null, or if it is null, take the value of false. Then Dart says, okay, then I am guaranteed to actually have a Boolean. So if this says null, then at least on the right-hand side, I have an actual Boolean. Again, go back to that example with the bag and the coins, okay? This bag is guaranteed to contain at least one coin, and this bag is not guaranteeing anything. It could just be completely empty, okay? So either an empty bag or a bag guaranteed to have at least one coin. Then it says, okay, I can at least fall back on this value of false if things go wrong, okay? So in here we say last name contains bar. And of course, you can also do it like this. If last name contains bar equal true. So what happened in here? So if you look at this operator, you can see that it's an operator that compares the value to the left-hand side with any other object, basically. So it says this could be any object, and that could be nullable. And to be honest with you, I personally like, I would say like this one more, simply because it is a lot more explicit that if this guy can't be resolved, then use the value of false. But in here, you have to really think a little bit. It's an optional. How are you comparing it to true? Some developers may not even know that this operator exists, okay? And if you run your code, let's see. If you run your code, you can see both of these are actually being resolved to the contents of the if statement, okay? Simply because last name does indeed contain the value of bar. However, personally, I would suggest using this, but it is a matter that you can perhaps resolve yourself, either you yourself if you're working with personal projects, or within a team of people. If you're working inside a company, you can together decide what type of convention to use, but both work fine. Let's close example 9 and let's go to then example 10, the usual dance, main, stop fs watch. Then we say example 10 in here. Okay. Now, you can call a function conditionally if the left side is null. So let's have an example. Let's have a look at an example. Let's say string get full name optional. Okay. And then we return foobar like this. So actually, let's make it an optional string. So we have a function in here which optionally returns a string. So it can either return null or it can return a valid string, okay? And then we'll have another function which does always guarantee to return a string. So we say get full name like this, and it always returns foobar. So you'd be thinking, but what just happening here? They're both returning foobar. So why is one of them written as an optional string and the other one as a string? The reason behind this is that the first function is not guaranteeing really returning an actual string. It does happen to be returning a string, but it can't guarantee it, because sometimes a programmer can then go ahead and say, in this case, I want to return null. But you can't do the same thing in this function because you're guaranteeing to return a string, so you can't return null. Okay, so we have these two functions in here. Let's go ahead and say final full name, either, take the get full name optional, which is an optional string, because you see now the data type of this full name is an optional string. You could say, take the value of that function, or take the value of this function. So again, the bag example, not guaranteed to have any coins, guaranteed to have coins. You see, it's not an optional. So the result is guaranteed to have coins, is a string, okay? Then we can print it, full name in here, and you can also put data type in here to be a little bit more explicit that this is of course a string, okay? And let's run our code. You can see the value of foobar being printed to the console. And that same value would have been printed had this function also returned null, because then it will rely on the value of the second function, which is to the right-hand side, okay? Okay, so that's that. You can also extend optional types using an extension that we're going to create in here, which we call describe. We will talk more about extensions later, but this is just an example. So this is for a little bit more those advanced users that perhaps are watching this course. I will give you an example of extending optional types, okay? So what we're going to do in here is to So the goal in here is to create a function that can describe an optional value. If the optional value is null, then the function will say this object is null. Otherwise, it says the runtime type of this variable is, for instance, a string or an int, and its value is etc. etc. Okay, so let's go ahead and create an extension which we call describe, and we create it on optional objects. All right, and then we say void describe. So we're creating a function, basically adding this function on top of all optional values or nullable values. Then we say if this is null, then we say print this object is null. Otherwise, we say print the runtime type is the value is equal to this. Okay, so we have this extension now. Therefore, we can go ahead and say final sum name is equal to get full name optional. So this is not a guarantee to actually be a value. It's an optional string. Therefore, we can go ahead and say sum name describe. All right. So you can see we're not forced to use this operator in here simply because our extension is on optional values. But if we remove this from here, then you can see we can't use the describe function anymore like that. We have to use it optionally. But since our extension is on optional objects, then we don't have to use the Null-Aware operator in here. Okay, so let's run our application and see what happens. You can see it says the string is foobar because it's falling into the else statement, and because this function actually returned a string. But if you go ahead and change this value to null in here, and we call that function, then we get a null value in here, and then we say describe, then it comes in here and says, is this null? Yes, it is. Then it will print this statement. So let's run our code. You can see it says this object is null. All right, so that was just an example for a little bit more advanced users who are watching this course. Good, we're done with example 10, the usual dance, example 11, and main function, of course, fs watch on example 11. All right, now you can also unwrap multiple values in Dart at the same time. And for this, I mean, it could be a little bit of a pain in the neck to actually do that. Other programming languages like Swift and Rust have better syntax, and specifically Swift, I would say, has better syntax for unwrapping multiple optionals. Dart doesn't, unfortunately. And this is one of the reasons I think Dart is kind of falling a little bit behind other modern programming languages in its syntax. I personally find Dart to be moving a little bit slower than other languages in its evolution. And it's very important for modern languages to ensure that they can compete syntax-wise with other languages. However, Dart hasn't taken that stance yet, but I know a lot of futures that I'm thinking about are coming to Dart, but I just wish that they could come a little bit sooner. Enough about that rant. Let's talk about unwrapping multiple optionals. Okay, let's create a function. And I also have to say, this is a little bit of a disclaimer. This particular example, as I mentioned at the beginning of this chapter, is increasingly more difficult to grasp than other examples that we've had so far. So the goal of every chapter is to build on top of every example and become more and more advanced towards the end. And in this example, what we're going to do is to create a function that takes a list of optional values and then calls a callback function if all of those values are not null, or none of those values is null. Okay, so let's start with saying that we actually want to have a function. We call it with all. Okay, so with all of these values that we give it, we want to get a callback if none of these are null. Okay, so we want to work with any object. That's why this generic type comes in. Okay, so we want to work with any object, and also we return optionally that object. All right, then we say, okay, in here, then we say list, take a list of optional values of that type. These are called optionals. And again, I completely understand this example could be way too complicated for some people. It's okay. I will do my best to explain it. If you don't get it, it's okay. You don't have to. You can come back to it later. But just know that given a list of optional values, we want to perform some work, should none of these values be null. All right. So given, like, let's say you have a first name and last name. All right. If first name and last name are both optional strings, if I can spell strings, how can you calculate a full name given a first name that is optional and a last name that is optional? Then you'll have to basically say if first name not null and last name not null. All right. So we want to avoid having to do that, and especially because in this example I just showed you, we're working with 2 optionals. But what if you're working with like 4 optionals, 6, 7, 8? Then you have to basically compare all of them with null. What if you don't want to do that? What if you want to do it a little bit easier? So you first take a list of optional values, and then you say, I want then a function that returns a non-optional value. So not a question mark, but a non-optional value is a function, which then takes a list of these values, which are not optional, and then we call it callback. All right. Then our function, what it does internally, it says, if this array of optionals, if any of them, let's say element, if any of them is equal to null, then return the value of null. Otherwise, call the callback, let's say callback optionals, and cast them to that particular value. Let's see, what do we call this callback like this? All right, so this code looks really weird, I understand, but this is what generics look like. All right, so you can pause this video right now and I will explain it one more time in here. What's happening is that given a list of any value that can be containing optionals, like an optional string, a list of optional strings. So this will work with like a list of optional strings. It will work with a list of optional ints. So let's just take string in this case and say t is string. And let's completely change this. Everywhere we see t, we replace it with a string. Okay, so string, 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 and string. And in here, cast string. Okay, so what happened in here is saying this function is working with this thing, and it returns, actually in here, we don't have to have the string anymore. So it says this function optionally returns a string because it takes a list of optional strings, and should none of these values inside this list be null, then it calls this function, which we give it with that same list, which is not optionals anymore because we've checked that. And whatever this guy returns, it will be returned from this function. But since this list could contain nulls, then the result cannot be a non-null value. All right. Again, go back to the bags example, which we talked about. So given this function now, we can go ahead and do some funky functions that use it internally. Let's create a function that is called get full name. And this guy works with a string first name and a string of last name, both allowed to be null. So what this guy returns is, it says with all, and it passes those optional values, first name and last name. Okay. And in here, if none of these guys is null, then it gets that parameter back in here. You can see is a list of strings. Then we can say names.join. We join them with a space in between like this. All right. Optionally, we return the value of empty in here. So in here, we say also names like that. Let's see if we can break this a little bit farther like this. So if you look at this example, this function, what it's really doing here is saying, put these nullable values in a list of strings. So the result of this really is let's see, it is a list of strings, optional strings. Okay. Then it says, okay, if none of these values is null, then take that list. You see, it's now a list of non-nullable strings. Then join those values with a space in between. So first name, space, last name. Or if the result of this entire function is null, simply because we fall into this category because some of the values in the list may be null. then the result of this entire function is going to be null. So it says either take the result of this, or if it is null, take the value of empty and return that from this function. Okay, so we can put it to test. Let's go ahead and say print get full name, and we pass null and null. So of course the result of this is going to be null. So let's, oh, sorry, empty, of course. Okay, so it says empty. And then we copy this and we say the first name is not null. So we say John, but the last name is null, meaning the result empty again is going to be printed to the console. Then we say, okay, the first name is null, but the last name is Doe, like this. Then we get empty again. However, if none of these values is null, then we get John Doe with a space in between. Okay, I understand again, this example was a lot more advanced than the other examples, but that's just the progression that we promised to do, or I promised to do from the beginning of the course and this chapter specifically. Okay, we're done with this example. Let's do the normal dance. Stop fs watch. Then we say example, I think it is 12 Dart. Okay, and let's create a main function and fs watch also on example 12. All right, now in this example we're going to talk about another function which we call FlatMap. Now this idea comes from Swift and Rust. They both have this idea of flat mapping optionals, but what does FlatMap actually do? Well, FlatMap is a function in Rust and Swift that allows you to drill down within an optional and grab its value and map it to another data type, perhaps completely to another data type or a different value of the same type, should that optional not be null. But if it is null, then FlatMap doesn't do anything, it just returns null. So that means that given a value of 1, you can change that to the string of 1. Or you could change it to the value of 1 again, or 2, 3, 4, or any other data type, an empty array. But if your integer is null, then the FlatMap function won't do anything and it will just return null. Okay, so it's a FlatMap is unwrapping and mapping an optional value. That's really what it does. Okay, so let's go ahead and create another extension on all optional values. We call it extension FlatMap, and it works with any data type T on optional of that data type. So in this case, T will, for instance, be resolved to integer if we're working with integer optionals, or string if we're working. So like basically we're saying where T is a string if we're working with optional strings. That's what we're saying. Or T is integer if we're working with optional integers. That's what this extension is resolving at the moment. All right. Then we say, okay, we return any value optionally, and we call our function FlatMap as long as it works with that data type. Then we say internally, we actually want a function that resolves this for us. So we say, given, if we can resolve this value for you, we're going to call a function. So we say, we give you that value and give us another value back of this type. Okay, so let's go in this function. Then we say, if, actually, let's create a shadow. Without creating the shadow, I actually want to explain this shadow thing. So let's say if this is null, then we return null. Okay, so we just say return null like this. Oops. Let's put our curly brackets and return null. Otherwise, now this is going to be interesting. Now we want to call our callback, right? We want to say, okay, we actually check that this object is not null. So let's call the callback, and pass this to it. That didn't work. What happened? So this is another shortcoming of Dart. In this case, Dart isn't able to understand that this is not an optional value. I mean, we've had a look at an example of this before, and we saw that it works, but this is the shortcoming, that this kind of operator that you're checking that something is null and then in the else statement that thing shouldn't be null, does not work with the this keyword. So first you need to shadow it. You have to put this into another variable. We call it shadow, for instance. Okay, and then you can compare shadow. You can replace this with shadow anywhere you see this, like that. then it understands that, okay, in this case, shadow can't be null because you've already checked. But if you did the exact same thing with this, it won't work, unfortunately. Okay, so that's why we have the shadow guy in here. So this is how our code looks like. And also we need to return the result of this callback. Okay, like that. All right, so this is how our function looks like. Then what we can do is to go ahead and start using that FlatMap function. So we say we have a string first name and we set it to equal to John, and then a last name, and we say Doe. All right, then we want to get the full name. So how do we do that? We want to get the first name and last name, and if they're not null, we want to construct a full name. So using our FlatMap function, we can say first name, FlatMap it, you see, okay, and then we get the first name. Then we say, okay, we want the last name as well. So in this, then we can say last name, FlatMap, then we get the last name. All right, and then in here we have access to the first name and last name. So we say first name and the last name. All right, and the result of this is an optional string. So if you look at it, let's put these into, let's see, some comma. All right, so the result of this is an optional string, okay, because either first name or last name or both could be null. So if first name is null, then this block won't even be called. It will just return, it will just go here and return null. But if first name is not null, then it will go into this block and provide you with the first name. Then in this block, what we're doing is saying, okay, now unwrap last name. Okay, so then last name, if it is null, then the result of null will be returned from here, okay? And therefore null will pretty much be returned from this FlatMap as well. But if last name is not null, then we're actually concatenating first name and last name with space in between and returning that from this entire block. Okay, so let's say final full name is either the result of both these FlatMaps or either first or last name or both are null. Okay, so we can then print the full name like this. So you can see the value of John Doe being printed to the console. However, if any of these values was null, let's test this. You can see it says either first name or last name or both are null, and we can change first name as well to null. You can see the result, the exact same thing being printed to the console. Okay, so that's for example 12. Now we can move on to example 13, and that is using default values for optionals. And this is just so we learn how Switch works with optional data types or data types generally. So let's go ahead and create example 13.dart, and we create a main function, fswatch, like this. Actually, let's go to our fswatch. I'm not sure what's happening. Example 13.dart. Oops. What is happening with my terminal? I'm not sure. Let's see. Do we have to type all that fswatch thing perhaps again from the beginning? That's maybe something that we need to do. I'm not sure exactly what happened to my terminal, but I think the syntax was kind of like fswatch, and then we say O, and we watch the bin directory. Then I think we go into xargs, pipe it into xargs, and we say n1, and then we say I like this, and then I think we do a shell and then C clear, and then we say dart, bin, and we say example 13 darts like that. I think this should do the trick. And then in here we say print hello, like something like that. Yeah, okay, that was the exact same thing that I thought it should be. Okay, then what we're going to do in this example, which is going to be even more complicated than the previous example, and that's for more advanced users. I mean, I can't create a course that is only for beginners or intermediate. I think this course should be like a blend of different flavors for different users. And this example is particularly more difficult than you would perhaps want to. But the goal of this example is to be able to grab default values out of optionals. And the And really the reasoning behind this and the inspiration behind this is Rust. Because Rust as a programming language, it has a really great feature which allows you to grab a default value out of any optional. So let's say that you have an int age, okay? In Rust, if you say age or default, something like this, it will either give you the value of age or it will say the default of any integer is 0. So you will then get an integer back. If you had a string, you said name, and you said name or default, it will give you either the value of name if it is not null, or it will give you an empty string. Okay, so that's where the inspiration comes from. So let's go ahead and create an extension on optional values and kind of do the same thing that Rust does, because I find it to be inspiring. So let's say extension default values, and we work on any data type as long as that data type is optional. All right. Then we say we always return a non-optional of the same data type. Then we say get is a getter, and we call it or default. All right. And then we go into this function. Then we create a shadow, as you learned from the previous example, which is equal to this. If shadow is not null, then we return the shadow. So what happened in here is that we're saying if the value that we're operating on, which is an optional value, is not null, then we actually use that value. We don't have to provide a default value, okay? However, if it's not the case, then we switch the data type, okay? So we haven't learned about switch statement before. For those of you who are not familiar with switch, then you have to wait until a little bit later. But as I mentioned in the beginning of this course is not built for people who are not familiar with programming from before. So that's a little bit of a strange situation we may find ourselves in that this course doesn't assume that you're a complete beginner to programming, okay? So let's then say, since we're switching on that data type, then we can say, okay, if we're working with an integer, then return 0 as an integer. If we're working with a double, then we return 0 as the double. Then we say if we're working with a string, then we return empty as that string, okay? Or if we're working with a boolean, a bool, then we return false as that boolean. And any other data type we can't resolve. We can say default, throw exception, no default value or type $t. Okay, so how do we use this extension now? We can go ahead and create a little function, and we call it get full name or full name. We say it returns a string. We say full name given an optional string of first name and last name. We want to calculate a full name. So how do we do that? Because either first name, last name, or both could be null. All right, how do we resolve the result of this to an actual string? Well, using our little default value extension. So we say we return, let's go ahead and create a string in here, first name or default, like this. So what happens is that we're saying that we're creating a string, we're concatenating the first name and last name into a string, and we're using first name if it's not null, or using its default value if it is null, and same thing with last name. All right, so then we can go ahead and start using it. So let's say print full name, and we pass null and null, and you can see now the result is going to be an empty string. You can't see it, but it's right here. Oops, clean the, okay, and run the application again. It is right here. It's an empty string. Okay, we could actually change that empty string to X so we can see the results. You can see it's X space X because the default value is being printed to the console. Then we can go ahead and say full name John and null. You can see now John is being printed to the console, and there's actually a space and an empty string in here. Again, we can change our default value to X, so you can see John space X, okay? And then also we can go ahead and say first name this time around is null and last name is Doe. All right, now you can see space Doe. All right, actually empty string space Doe, because the default value is again empty. We can change it to X. You see X space Doe. All right, and last but not least, we can actually provide it proper values, saying John Doe. And then since both of these are not null, then both of these will hit this statement in here, which returns the exact same value as this. So in this case will be John space Doe. There we go. Okay, good. This was the last example in the optionals chapter. It is outstanding, and to be honest with you, a little bit amusing for me that such simple thing could actually take a long time to explain. And we could have explained it in just one example and moved past this, but this is a course about Dart and its internals, and I find myself obliged to really go into details about things. And to be honest with you, I could sit here and talk about optionals for maybe 4 or 5 more hours, and we can go into like the binary code for this and actually do some disassembling of the code and see how Dart is internally dealing with optional values, okay? But maybe that's going to be for another course for those of you who are interested in that type of low-level analysis of Dart code. So now that we're here, before we forget, let's go into our terminal and actually commit our code. So let's say git add all, and we say git commit optionals. All right, good. We're now done with this chapter as well, and we can move on to the next one. So I hope to see you there.